I think we can start, sir. It's all right.
I extend a very warm welcome to all of you to the sixth Anoop Memorial Lecture for 2025. We hold this annual event in fond memory of our former student, Anoop, who lost a valiant battle against leukemia at a very young age. For this talk today, we have chosen a rather unusual but a very relevant topic. I have invited Dr. Priyanka Bhagade, who is a faculty member from IIT Kanpur. Having good conversation is said to be an art, but having a conversation with a Chat GPT is even more difficult sometimes if you don't frame the right kind of questions. And to that end, we have Priyanka navigate us through the canvas of navigating through LLMs. I'll now invite Krishna to introduce Anoop, and following that, Deva will introduce the speaker. Krishna.
Thank you, sir. Dr. Anoop was a wonderful person, an efficient resident, and loved by all. He was the ideal student and an inspiration to his juniors. His sincerity in clinical work, enthusiastic case presentations, and empathy towards patients were exemplary. Equally talented in sports, he always managed to find time for his two passions, football and cricket. Born and raised in Kasaragod, Kerala, he graduated from Calicut Medical College and completed his radiology residency with us at AIIMS between 2012 and 2014. His hard work earned him the prestigious Dr. Shyam Sharma Gold Medal for the Best Radiology Postgraduate of the Year in 2015. It broke our hearts when Dr. Anoop's journey was cruelly cut short on the 28th of August 2020 after a valiant battle against leukemia. Although fate stole him away from us too soon, Dr. Anoop will forever be a part of the AIIMS Radiology family. Today, on his 39th birth anniversary, we come together once again to honor his memory. I would now like to invite Professor Devasenatipati to introduce the speaker for this sixth Anoop Memorial Lecture.
Thanks, Dr. Krishna. Good evening, everyone. It's my pleasure to introduce Dr. Priyanka Bhagade to deliver the sixth Dr. Anoop Memorial Lecture on the topic of large language model prompt engineering in healthcare. She's currently an assistant professor in the Department of Computer Science and Engineering, IIT Kanpur. She also holds a PhD degree in Computer Science and Engineering from Arizona State University, USA. She's from engineering background, so that's the reason her area of interests are mostly technical in the technical front, which includes Internet of Things, sensors, mobile computing, application of machine learning, deep learning, and vision models into Internet of Things, as well as cyber physical systems. She also has deep interests in medical imaging analysis. And without wasting any time, I'll hand it over to Dr. Priyanka. Dr. Priyanka, please deliver the lecture. Over to you.
Hello, everyone. Thank you, Dr. Deva, for the kind introduction. So I will get started. Let me share my screen. Okay. So can you please let me know if you can see my screen?
Yes, ma'am.
Okay, perfect. So I am just adding a couple of more sentences to my introduction. So before joining IIT Kanpur, I actually worked in industry as well. So I worked at Intel Corporation as a computer vision architect. So I was responsible for working with Intel's customers to enable their computer vision applications on Intel's hardware. So I heavily worked on optimizing deep learning models for various computer vision tasks, out of which one of the tasks was medical image analysis. And since then, I realized that I'm really passionate about analyzing medical images. And I continued that research after joining. Am I audible? Right?
Yes, ma'am.
Okay. So in today's talk, we are going to discuss about how to do prompt engineering for LLMs, specifically for healthcare use case. Okay. So we have, all of us, we have been using ChatGPT or Perplexity quite a lot. Before we go into how to write specific prompts for specific queries or different use cases, I would like to give you a brief idea about what LLM is. So since I'm an engineer, you might feel that, okay, this is more towards engineering, but this is how I can think. If you feel that you are not understanding something, please feel free to ask me questions right away. I will try my best to answer your questions. Okay. So LLMs are basically large language models. It is considered that the LLMs are subpart of foundation models. So now you will see that, okay, already large language models is one of the popular models. Now, what are these foundation models? So foundation models are basically large pre-trained models which are trained on unlabeled and self-supervised data. So unlabeled data means there is data, but there are no labels. We don't know what that data is about. Okay. And self-supervised data, so where the labels are available. So these foundational models are not only trained on text, but there are foundational models which are trained on images, there are foundational models which are trained on audio as well. Okay. So the current models that we see, Chat GPT or Perplexity, they are all trained on text data. However, text LLMs are just a part of foundational models. Okay. So we know that these models, large language or foundational models, they are trained on extensively large data sets that include different books, articles, conversations. One example that I can give you is whenever you log in into certain website, or if you try to open a page, you might have observed that, or if you're logging into something, you might have observed that you get random alphabets and it asks you to enter those alphabets, right? Like you have to type those alphabets in. I hope all of you can relate to this example, that those alphabets were actually from the books. So Google used this strategy to digitize all the books. Right now as well, they are using this strategy to digitize the text, which is available in format of handwritten notes or books, so that LLMs can be trained. Okay. Another example is whenever you log in into certain page, you might see that, okay, it asks you a question that out of these 9 images where you see that, okay, there is a traffic light, there is a car, there is a pedestrian, or there is a zebra crossing. There are some examples where you actually annotate the images. I know this is slightly different from what we are discussing, but I would like to just give you an example that how we are actually helping these big companies to annotate their data, to label their data. Okay. Okay. So these large language models are trained on books and articles and different conversations, which are in the format of text. And when we say that, okay, these models are quite large, they are of almost size 1 byte or 1 million gigabyte as well. Okay. So since these models are really large, they need high computation power. So they need powerful GPUs to run these models. We can't really run these models directly on the CPUs that we have on our laptops. Okay. So you might have remembered that when this Ghibli thing got introduced by ChatGPT, right? Initially, Ghiblification of the images were infinite. Like you can ask ChatGPT any number of images and it will give you the Ghiblified image as an output. However, after a couple of days, they realized that people are processing large amount of images. So they added restriction. So the restriction was that you can only process 2 images in a day. It was added in order to save the computation power. So whenever we ask a question to these LLMs, in the background, we are actually generating large amount of carbon dioxide as well. Okay, because we are accessing large GPUs and we are requesting large amount of processing. So these big models, they The model size is dependent on how many parameters are there. So I won't go into details about the parameters, but you can think about how many units of neurons or how many units of convolutional layers or different layers are there, how large the model is. And for every model, there are parameters that learn as we train the model. So the numbers get trained, or the variables get trained in order to produce accurate output. Okay, and we call those variables as parameters. Okay, so I won't go into details about this because you, as an end user, you don't need to know the details about parameters, but if you are interested, I can cover it because I teach a whole course on it. Yeah. Yeah, so here I have added an example that, for example, GPT-4 has 1.76 trillion parameters, whereas Cloud 3 Opus has 22 billion parameters, and so on. So these models are quite large. Since their parameters are large, that means during training, these many parameters are actually getting updated. Okay, when we pass the data from books, articles, and conversations. In order to update these many parameters, it takes large amount of time. So in order to train these LLMs, it's not an hour or 2 hours of job. It's actually a job of couple of days or even weeks. Okay, considering we have access to large number of GPUs. Okay. So it was about what are LLMs. Now let's look into how LLMs actually work. You will realize when we will try different use cases for different prompts for healthcare, that why this information is important, because you get some background about, okay, what these LLMs are actually, how do they work, and then accordingly you can get more out of these Chat GPTs or Perplexity software or LLMs. Okay, so we can think of these LLMs as data plus architecture and training. We already talked about data, that in order to train these LLMs, we need large amount of data and then different sources from where these data points come from. Next is the architecture. So architecture is how the model has been built. So there is a transformer model that has actually enabled these large language models to handle sequences of data such as sentences or lines of code. So whenever you ask a question to ChatGPT or Perplexity, right, you provide sentences, but how can a model understand this sentence? And also we need to, the model needs to make sense of the sentence as well in order to provide you the output. Okay, as a human, our brain has been trained to process these sentences because we know the grammatical rules for every language that we speak. Okay, similarly, we need to teach these models, these grammatical rules. Also, we need to teach them how to establish correlationship between every word from the sentence. Okay, so that facility is provided by the transformer architecture. Once we finalize the architecture, then there is training process. So we know that the model gets trained on large data corpus to predict the next word in the sentence. So the classic example that we teach in the class while teaching any deep learning or AI related course is the sky is dash. So usually for sky, the next word prediction is blue. The sky is blue. If we are saying this sentence in the night, it should be sky is black. But the model should, we need to provide this additional information that it's night time, full stop, and then the sky is, then the model will predict that the sky is black. Okay, but since we haven't provided any information, the explicit assumption is it's daytime, the sky is blue. Okay. And if it's rainy season, then we provide that additional information. Okay, so we have to be more specific in order to get the accurate output out of these LLMs or out of any of these AI models. So these models can be fine-tuned on smaller or more specific data sets as well. So for example, if ChatGPT is trained on a generic data set, if we want ChatGPT to be trained on specifically on medical data set or we want to use ChatGPT specifically for question answering by healthcare professionals, such as all of you, then we can fine tune the ChatGPT model with very specific data set, which is specific to healthcare only, so that the model can extract better information from healthcare questionnaire and provide more accurate feedback to you. Okay, so there, apart from ChatGPT and Perplexity, there are some LLMs which are open made LLM. I actually, unfortunately, I did not get a chance to try that out today. So if you guys are interested, I can try it out after Diwali, and I can probably send a video or some information to Dr. Deva, and then he can share it among all of you. Okay. But for today's talk, we will be using ChatGPT only for the demo purpose. Yeah. So fine tuning can be done with very specific data set, and at that time we don't need a large data set, which is equivalent to the original data set. Okay. However, even for fine tuning, since these models are quite large, we need large compute power. Okay. So let's look at some business applications of LLMs, apart from the ones that we will be discussing today. So the classic example that I see every day here in IIT Kanpur is code generation. So none of our students like to write code anymore. Whatever assignments we give, they pass it to ChatGPT or Perplexity, and it generates code for them. So now we have started designing the assignment that we make it compulsory for them to use ChatGPT, or even if there are some courses where there is no such restriction of using ChatGPT, but then the assignment is so difficult that ChatGPT can't generate the complete code for it. So we, as a engineering college faculty, like we struggle a lot in designing such assignments because of LLMs, but we are also evolving with the technology. Anyway, so yeah, the classic example that I see every day today life is code generation. Another classic example that I see is content creation. People ask questions for, okay, what should be the content, or this is my problem statement. So for example, I was assigned to give this talk on prompt engineering for using LLM for healthcare use cases. So before creating this presentation, of course, my students helped me in creating this presentation. I directly asked ChatGPT and Perplexity that, okay, what should be the flow? The flow that the ChatGPT gave me, unfortunately, I did not follow the exact flow because I was not convinced that that flow will be useful. So I have chosen this flow. So let's see. So it depends on what story you have in your mind. So sometimes ChatGPT or this Perplexity, they work wonderfully. And sometimes, like if you have already thought about something that, okay, this is how something needs to be presented, then your thoughts might not align with ChatGPT, and that's okay. That you have to decide that, okay, how much content you need to take from ChatGPT, because ChatGPT is just a tool. You can't replace a person with this tool in most of the cases. Okay, then these LLMs can be used as virtual assistants that now users or customers of any product can directly ask questions to these LLMs and then get feedback from them. So we don't really need to assign a person there to answer customers' questions. It can be used for storytelling, candidate screening, transcription, preventing cyber attacks, sentiment analysis. So sentiment analysis is an interesting one, that if you are really mad at somebody and if you want to write an email, you write an email, because since you are really angry, your email might add that emotion, or the words in your email will have that emotion, and you don't want to break the bonds with that person. So you can simply write that email, pass it to ChatGPT, and just ask, okay, tone it down a bit, and then ChatGPT will give you wonderful output. Okay. So I just discussed the examples that I have seen till now. Then, of course, translation is a big thing. So at the start of this year, I went to Japan, and ChatGPT was actually a savior. because in Japan there are not that many people who speak English, especially local people. So if you want to communicate with them, you need a translator. So ChatGPT was actually a savior. So I used it heavily to convey my message to local people to move from one place to the other in Japan. Okay. So now let's look at how LLMs process prompts. So this is again related to how LLMs actually work. So for LLM processing is actually a multi-step process where we transform our plain English or human language into a format that is understandable by these AI models. Okay. So the first step is tokenization, where we break or the LLM breaks the sentence into smaller tokens. These tokens can be words or these tokens can be alphabets from the words in the sentences as well. So here we have taken an example of the cat sat on the mat. So it can be tokenized as the cat sat on the mat. So we can actually separate out each word in the sentence, and each unique token in the model's vocabulary is assigned a numerical ID. So each word here, each token gets assigned a numerical ID. So we just looked at at the start of this presentation, I mentioned that the transformer architecture actually gets used for processing these LLMs, or these LLMs are based on transformer architecture. So as part of the transformer architecture, it actually processes each word separately first, that with the tokenization, and these things like all these words. So how many words are there? 1, 2, 3, 4, 5, 6. These 6 words are processed simultaneously by different computing units in the transformer architecture. Okay. And during that processing, it actually looks, there is an embedding layer. It looks at each of these words and try to establish correlationship between them. So if you read this is very engineering and oriented words, but in general, I can tell you that these embedding layer actually tries to establish correlationship between these words in the sentence. They try to see that whether these words, whether the consecutive words or words, they belong to the same class or not. What is the distance between these words? By capturing the semantic meaning of these words, whether these words follow certain grammatical pattern or not, what are the meanings of these words, whether these words form different clusters, which parts of these sentence form different clusters. Okay, so the example that has been taken here, for instance, the embeddings for king and queen would be closer to each other than the embeddings from banana as compared to so the distance between the king and queen vector, we actually, at the end of the day, each word gets represented as a vector. So the distance between these two vectors will be less as with respect to each other as compared to their distance from this banana word. Okay. So this is how they try to establish the correlationship considering the semantic meaning. So whenever we ask a question to ChatGPT, it looks for this correlationship, and then for every word, it search in the database that, or it search in its knowledge base that, okay, what should be the output? What is the related information that it has related to these words? So now let's look at what is prompt engineering. So in order to improve performance of these LLMs, to address specialized task or to ask a specialized question, initially the traditional approach was to collect more data related to that question and then fine tune that model. Suppose today we want to ask a question related to healthcare. So we'll collect more data for healthcare. We retrain the model, that is, we will fine tune the model so that the model will understand that, okay, this is the information mentioned for healthcare. And now whenever there is a question related to healthcare, now I am in a better position to answer that question. However, with LLMs, now the approach has actually changed. Now we do prompt engineering. So this is a simpler and far more energy efficient technique because now we are not collecting data and we are not retraining the model. Okay. So what we do, we write the sentence and then we ask the Chat GPT to understand it and figure out the answer for it. Okay, instead of every time retraining the model for specific tasks, now the model itself has been trained on large amount of data corpus so that it can actually answer most of the questions. Okay, I will also, at the end of this lecture, I will also tell you where it fails. Okay. So here is an example that for English to French language translator, the prompt can be engineered as translate English to French. This is the task. Okay. So bread will be called as pain, butter will be beer, and cheese. I don't know. I don't speak French. So, and I did not check as well. So for any pre-trained model, that is LLM, or here you can assume that it's ChatGPT. We have this engineered prompt. Engineered prompt is actually the task. Translate English to French. And input is actually these words. Okay, so whenever you want to ask something, right, you have to first of all decide what is the task, and then for that task, what is your input. Okay, we will look at 3 different use cases, and then if you have more, if you want to try more use cases with me, we can try that as well. Okay, I am almost done. Okay, so now the first use case is using this GPT models. So all the LLM models are basically GPT based. So instead of specifically saying ChatGPT or Perplexity, we just call in general call that as GPT models. So GPT for COVID-19 diagnosis. So we will use LLM to determine whether a patient has COVID-19 or not. And the model will be provided with some initial symptoms observed in a patient like fever, cough, and fatigue, and then some physical examinations. Okay. And then we will ask queries, what test should I conduct? What medications should I start with? And what diagnosis should I consider? These will be 3 questions. Okay, given this scenario. We will try 3 different types of prompts. First, we will provide only this information and see what is the output. Then we will specify that the model should behave as a pulmonologist with 10 years of experience. And then we'll see for the same query, given this additional information, what is the output that we get. And then along with specifying the role, more context for the user for the patient, we will add that as part of the prompt and see that, okay, what is the output that we will get. Okay. So before I try this use case on ChatGPT, any questions on working of LLMs?
I think as of now, nothing. If there is something, we'll let you know at the end of the lecture, maybe.
Okay, sounds great. Either I taught it really well or it was all just
No.
bombardment of information.
It was nice. We'll just keep the questions on the end so that
Oh,
people can type and then we'll get you the
yes,
questions.
sure, sounds good. Uh, okay, so now let me do one thing. Let me share my complete screen because I have already typed these queries. I will be simply copy pasting. Can you let me know if you can see my screen?
Yeah. Yes, I can see.
Okay. So now the prompt is, I have a patient with symptoms, elevated body temperature, fatigue, and sore throat. Physical examination, systolic blood pressure being 92. My queries are, what test should I conduct? What medication should I start with? And what diagnosis should I consider? This is the case 1. Okay, so let's see what. ChatGPT provides us. All of you can see my screen, right? I just don't want you guys to miss.
Yes.
Okay. So actually based on the symptoms, it provided us some information. So I am not qualified enough to understand that what it has asked me, but you guys can, all of you can actually understand what is it has what is the feedback, what test should I conduct, and probably I will ask you guys that as I will change the prompts whether you are getting better information or not. That will be a good feedback for me too, whether my understanding of these LLMs are actually the theoretical understanding of LLMs actually work in practice or not. So what medication should I start with? So it gives some basic medications. And what diagnosis should I consider? So these are the diagnosis things that it has provided. And then non-infectious causes. Okay. So now, instead of the plain prompt, what if I add this additional information? Please assume the role of an experienced pulmonologist with 10 years of experience. Okay. And if I keep rest of the query as it is. Yeah. So now let's see what is the output that we get. Is it better than before?
Yeah, I think it is better, more concise, and it's more technical now in medicine point of view.
Yes, because now we have added additional information, right? Assume the role of experienced pulmonologist. So now think about this, that this model LLM has been trained on large amount of corpus. Okay. So whatever data it has been trained on, right? It just try, if we ask a very generic query, it tries to give us output with generic information. With the information, like whatever words are there, that what is the average information available related to those words. Since now we have added this pulmonologist, now it will start asking the input, or it will start producing the output which is related to this pulmonologist as well. Okay. Now, what if I provide in the next prompt, what if I provide more information about the patient, which is age, gender, and some health related conditions as well. So if I ask the same thing, then, and rest of the query is still the same. So now with the patient with 65 age, female patient with heart condition and weak immune system, I feel like the tests remained same. Is my observation correct? I think tests did not change, right?
It's the same.
Yeah. And how about this? I think this IV fluid explanation
Yeah,
has.
there is some improvisation, like the weak immune system. This is critical for preventing further decompensation. Is something which is new in this because
Yeah.
we gave this information of weak immune system.
Right. So, yeah, apart from that, I feel like, okay, there is some additional information here, but I hope all of you got the point, like what I'm trying to say. So if you, whatever output you want from the system, you have to provide that additional information. So whenever you ask questions to ChatGPT, if you say that, okay, you consider this role, then you will get technical feedback. Okay. Another test case that that I have considered is for the patient uh, who is on this olopatadine. I'm thinking of adding benzalkonium as well. can you tell me about any potential medication interactions that I should be aware of? So this can be asked by a normal patient as well. So it tells you the information about both the medications, and then it tells you the potential medical interactions or concerns that if the patient tries to take both medications together. Okay. Now for the same queries, if we tell it that please take the role of ophthalmologist with 12 years of experience and now ask the same question. Now it will provide more technical feedback. Now, even for these, like you might have observed that for the previous question, the language of these overviews for these medications were simple. But now if you look at when we have asked that, okay, assume the role of ophthalmologist, now the language for these medications, it is more technical. Okay. So this was a very similar example. And then in the next example, we have provided age as well. So instead of taking that, I would rather take the next example. This is the ICMR project that we are doing with AIMS Delhi, AIMS Gorakhpur, and DMC Ludhiana of figuring out or doing classification of ulcerative colitis and then provide MES score for that. So if we just ask, explain ulcerative colitis and MES score, this is from our actual experience. So this gives very basic generic information that we can understand. But if we provide the specific command that consider that I am an engineer and now explain me what is ulcerative colitis and MES score, the information that it will show us now, right? It is better understood by us as an engineer because it has less technical words. And then going further, if I ask that I am a deep learning research assistant at IIT Kanpur, I want to build an AI model for predicting MES score for colonoscopy images. And now explain me what is this? It provides better information than my previous question. So it also tells me for building an AI model, what I need to do. Dataset collection, pre-processing of colonoscopy images, what should be my model architecture, what kind of different models I should use. Then how I can, for model training, again, what are the considerations that I should have and how I can evaluate the models, the trained model as well. And then for post-processing and deployment, what I need to do, what are the challenges and considerations while training this AI model that I should consider, including regulatory and ethical challenges. And then finally, like it gives conclusion. So the final response was more appropriate for me as compared to the first two responses that we saw here. So these were just the outputs for the use cases that I tried. So now, after looking at these three use cases, here are some conclusions, again with some engineering insights. So whenever we directly query the prompt, you might have observed that we get generic responses. So the model is always inclined towards a certain bias because the model has been trained on large data set, right? So it just finds out information related to the keywords from that sentence. When we specify a role, then the generated response is more specific because it can also be viewed as trying to capture the variance of sample space. So variance is basically distance of any data sample from the average data samples. Okay, so the output that we get initially when we ask generic command or generic prompt, it all the response that we get is closely aligned with the average data samples. But when we specify the role, then we go towards specific samples. So we add this concept of variance into that. Okay, so we are not only considering the average data, but we are now considering very specific data. And then by finally providing more context to it, we try to balance this, try to get more optimal response with specific recommendations. However, the problem is now since we are providing more specific information, we will only get this skewed information because now we are moving away from the average information which is available. So that's why there is this bias and trade-off, bias and variance trade-off. So you really need to decide when you are asking questions to these ChatGPT or LLMs that how much information that you would like to ask this or you would like to provide to this LLM. If you want to be very, very specific, you provide large amount of information. If you want generic information to be added in that, then you need to go with the middle case that you are not providing complete information, but you are not even asking very generic question so that the LLM will only provide you feedback which will be provided to any patient. Okay, so that's the balance that needs to be achieved. Another important thing is since all of you are medical professionals, all of your data is very sensitive. You need to consider the ethical limitations as well, that how much information you can provide to ChatGPT so that you are not revealing any person's identity or you are not providing any patient's data directly to or any images or any reports directly to ChatGPT and asking it to summarize or asking any specific question related to that data. So these are some ethical considerations which need to be taken specifically in the healthcare setup. So that's it from my side. I hope I finished it in time.
Yeah,
Any
I
question?
think well in time.
Great.
So that was a very simple explanation for this very complicated topic of LLM. I think there are a few
Thank you.
questions in the chat.
Yes. So I had a question. Dr. Satyajit is asking this. As LLMs generate text by predicting most probable next token based on their training data, given this probabilistic approach, the likelihood of generating truly novel knowledge is low. That is true. In fields like medicine, whereas diseases evolve and new ones emerge, how can we ensure that LLMs remain relevant and accurate over time? So for that, fine tuning is important. That whatever new information is there, we have to pass on that information to LLM. And then, so either we train that model or other thing is during this in this prompt we have to provide this information as well. So for example that okay, now this disease has evolved and this disease also considers like these are also some of the symptoms, then LLM will consider that information too. So I can give you an example. I am it's not related to healthcare, it is related to one of the project that I am currently working on. It's related to IoT. So we are trying to figure out leakages in water pipelines using IoT devices and machine learning models. So we need to make this water distribution network. We are exploring one of the emulated tool emulator, which can actually build this water distribution network, and then we can try out our machine learning models. We can try out our different methods that, okay, where the sensor should be placed at what distances and all those things. So ChatGPT is not aware about the emulator that we are using, right? So what we did, we provided all that data sheet for the emulator in the as part of the prompt to ChatGPT, and we have asked, now given this data sheet, tell us how we can create this distribution network and how we can add AI agent as part of this emulator. So ChatGPT studied that. Of course, we have a paid version of ChatGPT for the research purpose. It studied it, it trained itself, means it understood it, and then it provided us good feedback. So similarly, like that's what we need to do. But you are absolutely right that we cannot actually, like, it's very difficult to keep up with the new changes. So that's why it is important to retrain it. But one of the strategy is like providing additional information through these prompts, and it works quite well. Another thing is these tools or AI is not there to replace clinicians. Means you guys are never replaceable. You will observe as you will start using it, right? I gave you an example that when I was actually building this presentation, you can even give this prompt, that LLM prompt engineering for healthcare. I did not like the flow, so I just stick to the flow that I liked. And that happens in most for me for most of the research questions as well. It provides me good feedback on what is the related work available. It provides good suggestions that, okay, in which direction I should think about. But I have observed in many cases that their suggestions are so generic. Sometimes they are excellent if I want to modify any text. But sometimes from the research purpose, I feel like it's just giving me the same ideas which are already available because it is only trained on that. So if I want to think something innovative, I have to think on my own.
Thank you, ma'am, for that very lucid presentation. I request Sanjay to invite any questions or to make any comments.
Yeah, thank you, Dr. Bhagade. That was truly illuminating talk on a frontier which is relatively new to a lot of us.
Yeah.
And given that we stand on the crossroads of human and artificial intelligence today, this discussion could not have been more timely. So, on behalf of the Department of Radio Diagnosis, I extend our sincere appreciation for your contribution. And we can carry on with the questions and comments. There are a few questions I can see there are in the chat. I can probably maybe read it out. Deva, can you see them on your screen?
I can.
Yes, sir. One of the question is from Dr. Amit Mahendratab, who's
Okay.
also a good friend of mine. He is in IIT Delhi. His question is, how do you avoid hallucinations or information that is an extrapolation of the reality? Basically, how to avoid hallucination by the LLMs.
I think it is difficult to avoid, but easy way to avoid these hallucinations is what I have observed is you ask the same questions in different ways. So when you are asking these questions, like the prompt engineering, we looked at different cases that how we are adding extra information. So you just observe that, okay, you first of all start with a very generic question. And then you look at the answer. When you add specifications, like when you add extra specifications, you might start observing that the model might start hallucinating. So my recommendation would be that, okay, don't just blindly trust the output of LLM. So for code generation, like the tasks that I see that students heavily use, the those codes they don't always work. At least I haven't seen the code like which works completely. So every time you have to just keep on asking modified questions that, okay, this is my task now, what should be, please generate code for this particular task. You look at the code, it won't be directly applicable to your question, then you provide more specifications. So it's like a step-by-step process. That's the only thing that we can do as end user. That prompt engineering is in our hand.
What if we ask the same question twice? Will that avoid hallucination? Or it'll have that memory of the previous answer?
No. That's not like every time you ask, right? you will get similar answer, but not word by word exact answer.
Okay, will that avoid this hallucination? Because uh, I mean, only consistent things will be, real, right?
No. So
Okay.
here is the problem. This is a game of probabilities, right?
Right.
So like 98 to 99% you will get similar answer, but that 1 to 2% will vary because you are assigning probability to the output information or probability to words which are spit out of these LLMs, right? So sometimes some words might get a bit higher probability than the threshold. So there will be some words which are sitting at that particular threshold. So if the probability for those words crosses that threshold, they will be your output. So
Got it.
yeah, instead of like this, I can give a very simple example. I heavily work on computer vision. If I train a model to detect cats in a given image, okay, so let's say just classify, just say that okay, whether there is a cat in this image or not. Every time I run the model, I might not get the exact probability. If the first time when I run this model with image A, which has a cat, if my output is 98%, next time I might get 97.9% as well. Because at the end of the day, it's probability, right? We are not saying exactly, okay, 97.9% with this probability. I'm saying that there is a cat in this picture. So same thing applies here as well.
Dr. Priyanka, we were talking mainly about Chat GPT, but there are so many other LLMs also. Each of them have their own USP. Each of them is better at a particular task. Is there something like that? And do the LLMs understand their own shortcomings? And if you were to ask that which LLM is best at doing this task, say writing a letter, would they give their own name or would they suggest the other LLM?
See, LLMs won't suggest other LLMs because it's business, right? They don't want to get their customers out of their hand. Right now, everything is free, but slowly you will start observing that they will start paying us because once we start getting dependent on them, right now, like humans are not completely dependent on LLMs. But after 2 years, that will be the business strategy. Right now, OpenAI is actually like, I don't think it's earning anything from ChatGPT, but that I am expecting that will be their business model. Once we completely start relying on them, then they will start charging us, similar to Google, right? Previously, like whatever images we were storing on Google Photos, everything was free. Now they have put the limit of 15 GB. So another question, that the main question that you have asked, whether they understand their limitations. So they do understand their limitations. So the limitations are basically these hallucinations, or if you provide very generic information, or they might not be up to date on the latest information which is available in the market. So for example, if some product gets released today, ChatGPT won't know about it because it's not trained on knowing that product. But if you provide information that, okay, this product has been released and this is what it does, then it will start comparing that product with other on the data that it has been trained on. So think about it like a human brain, that whatever information we have, we can answer those questions well, we can reason about those questions. So LLMs have actually started reasoning like humans, that if we get to know about new product or new thing, we try to correlate that, okay, this is new language, how this language is now correlated with the languages that I know, right? Similar thing they also do. Yes, and ChatGPT is for text, as I have mentioned that there are LLMs or foundational models which are specifically for images. There is this open medical something LLM which is specifically trained only for healthcare data. Yeah, as I said that unfortunately I did not get a chance to explore that today. It has been a busy week. So yeah. And then of course Perplexity is there. Gemini is there, BERT model is there. There are lots of models. Actually, every big company, they are coming up with their own model. And So as you will try it out, you will realize that, okay, which LLM is working well for you, that you have to decide. If you ask me this as a personal question, I am yet to rely on LLMs, so I hardly use it. So since I had to give this talk, I actually did some search. Otherwise, I don't use it that much. I prefer using Grammarly if I want to, whenever I'm writing a research paper. But apart from that, I am also yet to get used to LLMs or using LLMs.
Any other questions,
Huh?
comments?
I think there is one question from Kritika, which is, what is your experience on the use of LLM with prompt engineering alone versus using RAG versus using a custom SLM, small language models, particularly with a view of avoiding hallucinations? Again, related to hallucination.
Yes, related to hallucinations, if just a second. Just a second, I just need to take this call. This is from my daughter. Okay. Sorry. Huh. Where was I? Huh. In terms of hallucinations, I think SLMs will work better. But the only thing is, since these are small language models, they are trained on low corpus as well. So you won't be able to ask all sorts of questions which you can ask to ChatGPT or Perplexity or Gemini or BERT. Okay. Another limitation is from RAG-based models. So RAG-based models is basically AI agents, right? AI agents based. So these AI agents, what they do is they actually take, it's like a filter. These agents study the prompt. They provide additional information to LLMs. So in prompt engineering, when we said that for the first use case, that if I'm consider that you are an experienced pulmonologist and now answer this question. So this is an additional information. So the classical example which I teach in my class when I teach these AI agents or these rack systems is, suppose if I ask ChatGPT that when is my coffee date today? So ChatGPT won't be able to tell me because ChatGPT does not have access to my calendar. But instead of that, if I use RAG and connect my calendar to RAG or AI agent, then my calendar, the RAG will know that, okay, this is my calendar. And now it can provide that information to ChatGPT, and ChatGPT will provide me answer that, okay, you have a coffee date today at 3 o'clock. So basically with AI agents, you are providing additional information which is not accessible to ChatGPT because it is trained on the existing data. But what if suddenly something changes? Then it is available. So for example, if you use AI agent with for weather conditions, if suddenly some weather condition changes and if you ask that, okay, considering today's weather, which food I should try. So if you have AI agent for weather, AI that the latest current weather information will be provided to ChatGPT, and ChatGPT will say that, okay, today's temperature is 25 degrees Celsius. It's in India. So you can either try, since it's evening, so you can either try light food or it can give you different options. Right? Because now ChatGPT is trained on for different temperature, what food the person can try. But since ChatGPT does not know what is the weather right now, it does not provide you accurate information without these AI agents. Unless you provide that information that, okay, today is 25 degrees Celsius in Kanpur, what food I should try, then ChatGPT will provide you the answer. I hope it made sense.
It can personalize things, and it acts as a bridge between the LLMs and the personalized information which you like to give to the LLMs.
Can't it surf the internet and train on the fly? like human beings.
So training
Let
on
me
the
ask you a
fly
question.
is training on the fly is from this prompt engineering, right? You provide that information.
Deva, I have one question, one hand raised by Dr. Amit Mendireta. You want to
Yes.
read out the question, or you want me to read it out for you?
I think I've already.
No, I
you
have
had a
another
question.
question, Deva. Yeah.
Yeah. Please go ahead.
Yeah. Thanks, Priyanka, for a wonderful talk. I think very appropriately timed. I have one question, like just for the larger audience, also you can elaborate. Nowadays, we are getting many queries from students, and I just recently reviewed a paper. They said that if you take an LLM and ask some specific questions to relate it to a particular problem statement couple of times, can you restore that subset of LLM as a specific trained model for some particular set of questions related to particular disease, and you can claim that that's a LLM for X disease? Because that is something which has recently started evolving and I'm facing some issues. What is your viewpoint, and is it that easy?
I don't think that is that easy. Because when you are saving this LLM, right, you need to save that particular instance. So if you have logged in into LLM, then it will save all of your user history. Right, that okay, these kind of questions that you are asking to LLM. But one thing that I am not sure that how long it can actually store, like what is its memory limit, or how long it can store that information. So when you say that, okay, you are saving the model, so I don't know how long it can actually be consistent with that information. That actually I did not try. So I guess I am not in position right now to answer that correctly.
Yeah, that's a very recent addition, because right now we are getting some papers to review which claim that we have used the Chat GPT, created a subset of it with a very specific clinical domain experts asking very specific prompt questions, then filtering it so that the data, that the answers that create make sense, and that subset can be used to train the junior residents in that particular disease specific condition. So it's a very
Right.
niche area, so I just opened it up for the larger audience to understand, so that not to get misinterpreted. It's just a thought that we recently
Right.
started getting comments. Yeah.
Yeah. So what I understood from your explanation is basically you are asking very specific questions to ChatGPT, right? And then you are getting some output out of it. And then you are using that output, whatever output text is there, to train the junior engineers. But then where you are saving the model, are you saving the model or are you saving the
Yes.
output of the
Yes.
model? So there is a difference.
Yes. No, you are saving the retrained model. That is
Re
what the authors claimed. I'm
Really?
also not sure. That's why I asked you, is it possible?
I haven't came across it yet, but I can check and then probably I can send my
Thank you.
back to Dr. Deva, and probably Dr. Deva, if you can communicate, that would be great.
Sure.
Yeah.
Thank
Sure,
you.
Doc.
We encourage any of the residents to ask any questions, any of the junior residents who are not part.
Dr. Amit raised his hand.
Amit, can you please go ahead with the
Amit, you want
question,
to
please?
ask?
Yes, sir. Good evening, sir. Good evening, ma'am. Thank you for the talk. And I just wanted to chip in on the question that Amit sir asked. Sir, as far as your description is, and as far as I have experienced the GPT and its features, so I think what you are describing is the custom GPT feature in within Chat GPT, but it's more like prompt engineering itself, where you can basically store a prompt for that subset of the GPT, and every time you give a instruction or a specific question to that GPT, it automatically uses that prompt that you have already saved. So
Okay, makes more
I
sense.
don't think, yeah.
Huh.
So I don't think it's retraining or fine tuning. I think
Okay.
it's just saving
It's
the
just prompt,
prompt.
prompt engineering. Yeah.
Yep. This is what I think about
Yeah.
the idea that you suggested, sir. Yeah.
So actually, like whenever I use or the students use ChatGPT or Perplexity, we log in into our account. And then it knows that, okay, what kind of questions we ask, and it stores those prompts as well. So,
Yeah.
yeah, Dr. Amit, if you have any paper which says that, if you can send that to me, I won't share that with anybody. If you are reviewing those papers, I know the confidentiality. At least I will get to know that, okay, what exactly
Sure.
you are referring to.
Sure. Thank you.
And I will be
Priyanka, go
glad if
ahead.
I can
You're
learn
up.
something. Yeah. Thank you, Dr. Amit.
And I think Ankur also has a question. Are LLMs trained to provide different answers to the same non-factual query by different user? For example, 100 people asking ChatGPT what is good thesis topic in COVID-19, will answers be the same or different?
Again, it's the game of probability.
Okay. So
Yeah.
if it's a game of probability, then most likely the same things will come up, or
Same things will come up if you are not logged in into the system. But if you are logged in into the system, it's like a reinforcement learning. It's like a loop.
Mhm.
So it considers your previous questions as well. That okay, you asked these kind of questions. So it might consider some feedback from your previous questions too.
So that means it might give customized responses based on the prior history?
Yes. It
Okay.
It might, but if it is just COVID-19, right? Like it's such a generic topic, I would expect that you should not expect that much of a change. So this is very similar to whenever you do Google search. Like, eh, suppose you do a Google search for asking about AI models. The output that you will get and the output that I will get will be different. Slightly different for sure. Same thing happens with LLMs as well, because my search history is different. And if I try to search something related to medical, of course, your output will be far better, far more technical than the output that I will get.
Okay. So that means right now the LLMs are in the stage that they'll give the factual information maybe correctly based on all the data which has been fed into them. But regarding anything which is like extrapolation from that, we don't know how reliable the answers will be. Is that
Right.
right?
So, yes. So hallucinations will play a role there, actually.
Okay. Okay.
Okay. So
Thank you.
that's why we have to verify that,
Okay.
okay, whether this answer is correct or not. That's why I'm just keep on saying that it's not to replace clinicians. It's not to replace humans. It's to help us.
Ritika, you had a question?
I think she.
Yes, I was just wondering if we still have time to ask.
Yeah, go ahead.
Okay. So my question was around zero shot and few shot learning. So again, what has your experience been in terms of again increasing the reliability of the output? Do you often use these techniques? Does that make it more reliable for you? Just given that hallucinations is actually probably one of the biggest problems as far as healthcare is concerned.
Right. So I have heavily used zero shot learning and few shot learning with non-LLM models, because I don't have that much GPU capacity available with me, and I don't work on training LLMs. I use them, but I don't train them. Okay, so I can talk about using few shot learning or zero shot learning. There is continual learning approach as well, which kind of all fall into similar category, that you have trained the model on a big data set uh, for LLMs. So for example, and then you have a very niche field. So for example, now this ChatGPT is trained on large amount of corpus, considering information from various areas. It's not only trained on healthcare applications. So for example, if you want to train ChatGPT only for healthcare, right? There you can use this few shot learning, that with minimal samples as well, you can train the model. So that is part of fine tuning.
Sure.
And then that helps you to, or that helps ChatGPT to avoid hallucinations as well. So easy example can be, if I trained, so I can give computer vision examples rather than these ChatGPT ones, so that I can be very, very specific. If I trained a model for classifying different birds, if I trained the model in for birds from 10 different categories. Okay, now I realize that, okay, I have 11th category of the bird as well, but I don't have that many data samples. What I will do, I will simply use zero-shot learning or few-shot learning, and I will retrain the model with these minimal 11th class of birds images, and the model will then start classifying 11 classes of birds. Or you can even make it classify only 11th class. So that you need to decide how you want to train it. But this is how it works. So then you can actually apply the same analogy for LLMs as well.
I think the discussion can go on forever because this is such an interesting and current topic that and there's so many questions to be asked. But in the interest of time, I think we'll conclude this session. And on behalf of the Department of Radiology at AIIMS, I thank Dr. Priyanka Bhagade for sparing her valuable time and for giving us this very lucid talk on a very complex topic. Thank you very much. And thank you to the audience for joining me.
Thank you.